All right, so this is about domain, range, functions, and relations. So domain, if you remember from Algebra 1 and Algebra 2, is the input values or the x values, and then the range is the output values or the y values. And a relation is something that shows the relationship between the input and the output. More specifically, we have functions, and functions are a subset of relations that have one and only one output for each input. So you can say that each x only gives one answer for y. So let's start with evaluating. So we have this function f of x, and f of x is just kind of the fancier way to say y. So this is function notation, and that just means y. It says f of x is equal to x squared minus 10x minus 3. So this means that we are taking x and letting it equal -1. So we're going to plug in -1 squared minus 10 times -1 minus 3. We can put that whole thing into our calculator, or we can do some mental math. So 1 plus 11 is 12 minus 3 gives us 9. So we could say f of -1 is equal to 9. You can also plug in a binomial for x. So this is saying that everywhere that we see x in the original function, we're going to plug in that binomial. So here's that first x. So we're saying x plus 2 squared minus 10 times x plus 2 minus 3. So then we just need to calculate. So we have x plus 2 times x plus 2. And that gives us x squared plus 4x plus 2. We're going to distribute the -10. So minus 10x minus 20, and then minus 3. And then we'll finish up by collecting our like terms. So we get x squared minus 6x and then minus 21. So that's f of x plus 2. We're going to do a lot of that in this unit, so that's something that you want to be comfortable with, not only plugging in numbers, but also plugging in variables and polynomials. All right, and then the last one, we have f of -x, so we're plugging in -x everywhere that we see x in that original function. So we have -x squared minus 10 times -x, and then minus 3. -x squared is -x times -x, and that would give us a positive x squared. Then we have -10 times -x, so plus 10x, and then minus 3. So one way you can evaluate a function is plugging into the function. The other way that you can evaluate a function is from the graph. So let's do a couple of those. So when we're evaluating from a graph, we need to remember that this whole thing is y, and it's telling us, so it's asking us, what is y? So y equals what? And at the same time, they're telling us x is 0. So we're going to go to the graph. We're going to find where x is 0 and then locate our y. So at this point right here, y is equal to -1, 2, 3, 4, 5. So f of 0 is equal to -5. This means find the y value when x is equal to 1. Okay, so if x is equal to 1, that's right here. An open circle means the graph doesn't exist there, so we need to go to the closed circle. That's also -5. Okay, the next one is saying that what is y when x equals -5? So let's go to -5 right here. And if we go up to our graph, the y value at where our graph is equal to 2. I'll do one more with you. So this means that x is equal to 3. And where's our graph when x is equal to 3? Well, it exists up here, and that's about 3.5. Okay. So we can also use the graph to evaluate. See if you can do those other 4 on your own. Okay, I'm going to come to the back and then we'll finish the front page because this kind of goes along with what we just did. So this is a piecewise function. Piecewise functions are 2 different functions that happen within the same problem. It's really important when you are doing a piecewise function to pay attention to your domain restriction. So where is x happening when? So this first one, they're asking us what is y when x is equal to 3. So x is equal to 3 applies to the part of the function of x being greater than or equal to -2. So we need to use this bottom part of the piecewise function to evaluate. So our answer is just -4, sorry. So this is just equal to -4. Okay. Here, this is telling us that x is equal to -4. Well, -4 is less than -2. So this time we need to use the top part of the piecewise function. You'll notice here that there's a variable or a place for that x to be plugged into. So we're going to plug in -4 for that x, because that's what they're telling us that x is equal to, plus 5. That is obviously equal to 1. So f of -4 is equal to 1. Let's do one more. Okay. All right, so this time we have, they're telling us that x is equal to -2. So we need to use the part of the piecewise function where x is greater than or equal to -2, and that would be this bottom part. So again, our answer here is just equal to 4. So you need to determine which part or which piece of the piecewise function you're using by the domain. So does x apply to the first part or does x apply to the second part? And then whichever part it applies to, you come over and you use the function for that. Sometimes you need to plug in your x value, and sometimes your x value is just that, like there's nowhere to plug it in and it's just that number, like that -4 example. Just want to show you what this looks like as a graph. So the yellow part of the graph where x is less than -2, so here's -2, is this part right here. That's x plus 5. And then the second part of the graph when x is greater than 2 is this second part here. And this is when x is greater than or equal to -2. And this is when f of x is equal to 4. So you can see the 2 pieces. I highlighted them so they correlate over to the function as well. We will spend more time with piecewise functions in this unit. We're going to spend some time graphing them, so we'll get really comfortable with them. Understanding this domain part is really essential for you to be successful with piecewise functions. Okay. The second thing that we're going to do, since after evaluating, is we're going to determine if a relation is a function. In order to be a function, the x values cannot repeat. So here, the domain is, remember, the x values. So I'll highlight those. So our domain would be 4, 6, 8, and we don't write it twice. But because there's 2 8s, this is not a function. And it's not a function because x is equal to 8 has 2 different y values or output values. Okay, let's look at some graphs and see if we can determine if y is a function or a relation. So the first thing that we want to do is we want to set, when we have an equation, we want to set it equal y is equal. We want y isolated so we can tell. So I'm going to minus 3x from both sides. I get 4y is equal to negative 3x plus 16. Then we'll divide by the 4. So negative 3/4 x plus 4. Okay. Every time that I plug in a value here for x, I'm only going to get one y value out. So this would be a function. The other way that you could tell is if you look at the graph. So the graph of this function will look something like that if I sketched it out. It's linear, and it passes what we call the vertical line test. So the vertical line test says that if I draw some vertical lines, every single time that I draw a vertical line, it touches the graph one time. That means for each x value, I'm only having one place on the graph, so then it is a function. Let's take a look at the second example. So again, we're going to isolate y. I'm going to minus x from both sides. I get y squared is equal to x squared plus 16. I'm going to isolate y. So now I have to take the square root. So we get y is equal to plus or minus the square root of x squared plus 16. Now this is not a function. And it's not a function because when I plug a number in here for x, I'm going to get two different answers. I'm going to get a positive square root, and at the same time, I'm getting a negative square root. So because one x value is giving me two different answers for y, I cannot consider this to be a function. This graph, when we look at it, the positive side looks like this, and then the negative side looks like this. So it should be a circle. My graph's a little wonky, but imagine a circle. So when we test out the vertical line test, we can see right away that the graph is being touched by that vertical line here and also down here. So that's the other way that we could always tell that it's not a function. So in this video, we did two things. We evaluated functions a couple different ways. We talked about evaluating piecewise, and then we also talked about determining if relations are functions.